Hello and welcome to EduSathi. Continuing our topics of algebra, we'll move to maxima and minima. As the name suggests, maxima and minima refers to the maximum and the minimum points. So this maxima and minima is the maximum value that can be attained, and what is the point at which that maximum value can be attained will be known as the point of maxima. So point of maxima is the point where the maximum value is attained, and what is the maximum value is your maximum value. Similarly, in case of a minima, I can find out the point of minima. That means what is the point where the minima is attained and what is the minimum value of the function. So if you look at it, every point on a coordinate axis has x coordinate and y coordinate. X coordinate is known as point of maxima and y coordinate will be known as the maximum value. Similarly, x coordinate is known as the point of minima and y coordinate is known as the minimum value. So you have to attempt the question very carefully. Is it asking the point of maxima or the maximum value? Is it asking the point of minima or the minimum value? So point of maxima or minima is the x-axis thing, and the value, maximum and the minimum value, is the y-axis thing that we have. Now we are at the second last topic for algebra. You could see we have done all these topics. In case you haven't gone through all the topics, you should go back and look at the other videos that we have based upon the contents. So the first type that we are dealing with the maxima and minima is the type of quadratic equations. There are basically two methods for solving the maxima and minima problems for a quadratic equation. One of them is the method of perfect squares, and the second method is using differentiations. We'll study both the methods with the help of an example. So the first method that we have is a perfect square method. Perfect square method means try to convert this quadratic equation into a perfect square. How do you do that? You look at the coefficient of the term with a single power of x. Half the coefficient, so if it is b, divided with 2. Now before doing this thing, you have to make sure that this a is 1. If a is not 1, that means the coefficient of the term with the highest power of x is not 1. Divide the equation with the a so as to get to a simplified version of it. So let's take an example. It is x square plus 6x plus 4. Now the value of a is already 1, so I need not worry about it. What I have to look at is the coefficient of the term containing single power of x. Now that coefficient or the value of b comes out to be 6. I will half it. Half it means it becomes 3. Then square it. It becomes 9. Now once you half it and square it, this is the two-step procedure. Half it and square it. Then what you do, you add and subtract the same thing. When you add and subtract the same thing, it really does not change anything in the equation, but it will help you in completing the square. So x square plus 6x plus 9 would be x plus 3 whole square, right? And this 4 and 9 would combine to give you a value which is minus 5. Now this is the value of the function that you will get. So this thing is written in the same way. So first I am dividing the equation with a, then half the coefficient of b, square of it, added and subtracted. When I add it, it is combined with the square. The rest of the terms have to be arranged to get to the value of the constant. This is what is done. Now if you look at it, now fx is composed of two things. One is x plus 3 square and other is minus 5. Now this is a square of a number. Now square of a number can never be negative. The minimum value for a square of a number is 0. So this value would turn out to be minimum at what? When I put x is equal to minus 3. So fx will turn out to be minimum because this value is always what? Positive, or the minimum is 0. So if you put x is equal to minus 3, this will turn out to be 0 and the value of fx will be minus 5. So point of minima will be minus 3 and minimum value would be minus 5. This will be how you will find out the minima of this equation. Also, if you remember the graphs, this is the graph when a is positive. So I will get what? I'll get the point of minima or the minimum value. There will be no maxima attached to it. Whenever you have a graph where a is less than 0, then you will have a maximum point or a maximum value associated with that kind of graph. Let's look at the second method that we have. The second method is the differentiation methods. So in case you are comfortable with differentiation, you can follow this method. Otherwise, I'm going to tell you a shortcut in the next slide. So I'm taking the same question. You have to find the minimum possible value of this expression. So what you'll take fx is equal to x square plus 6x plus 4. Now I'm going to take a derivative of both sides. What is it? It is 2x plus 6. Now put this derivative equal to 0. So 2x is equal to minus 6, x is equal to minus 3. So the point that I get, the point is x is equal to minus 3. If you put back the point here, you will get the value. So fx will be minus 3 square, which is 9, plus 6 into minus 3, which is 18, plus 4. 9 and for 13 minus 18, the value is coming out to be minus 5. Same was the case that we got when we used the perfect square method. And also, if you can find the double derivative for this is coming out to be 2, which is what? Positive. So if the second derivative is positive, it is a minima point. If the second derivative is negative, it's a maxima point. So if you are comfortable with differentiation, go ahead with this method. If you are not, then this is the method that we need to follow. This method would be separated into two cases, when your a is positive and when your a is negative. If the a is positive, the graph that you will get would be a graph which will be upward facing graph. Now in this graph, the value of the function would turn out to be maximum when x is maximum. So if you keep on extending this graph up to infinity, the value of the function would come out to be maximum. However, you can find out the point where it attains the minimum value. Now this point will have both x coordinates and y coordinates. Now if you look at it, this point is basically lying on the axis of symmetry for this quadratic equation. Now alpha and beta are the two roots of the quadratic equation. So this point, which is the point of minima, is actually located exactly in between alpha and beta. So for this point, the x coordinate will be alpha plus beta by 2, exactly the midway. What is the sum of the roots that you have? The sum of the roots is minus b by what? 2a. So what you will look at it, minus b by a, so it will give me minus b by 2a. So the value of x coordinate, which is the point of minima, would be minus b by 2a. You can find this value, put back the point in the equation and find the minimum value. If you don't want to do that, you can just simply remember the point as minus d by 4a. X coordinate minus b by 2a, y coordinate minus d by 4a. In the second situation, when your a is negative, this is the graph that it looks like, you cannot find out the minimum value because the minimum value would lie when x is minimum, which is turning out to be a case of infinity. However, you can find out the maximum value. Now again, this maximum value will have x coordinate and y coordinate. X coordinate will be known as the point of maxima and y coordinate will be known as the maximum value. Now this point of maxima would exactly be the midway between alpha and beta, which is again the product of the roots. So this point would still be at minus b by 2a. Same value that we have remembered here. So there is no new value that I have to remember. And the maximum value would also be the same, minus d by 4a. You need not do any adjustment with the minus sign, because when a is positive and a is negative, the minus sign would automatically be adjusted. So this is the only thing that you have to remember, which is what? Minus b by 2a will be the point of maxima or minima, and minus d by 4a will be the maximum or the minimum value. Now the second type of questions that can be there in maxima and minima is, given a sum, what is the maximum product? Now the rule for this is, for a positive variable, if the sum of variables is constant, then the product of the same variables will be maximum if all the variables are equal. Now what does that mean? If a plus b is equal to something which is constant, the maximum value of their product is when I put a is equal to b. That is what the rule says. So if you look at it, if you take a simple example, if a plus b is equal to 4, let me take that value. Now what are the possibilities? This could be 0 and 4, this could be 1 and 3, this could be 2 and 2, this could be 3 and 1. And if I am talking about positive, I will discard this case. What is the product of AB? It is 3, 4 and 3. So the product is maximum when the numbers are equal. Let's look at an example. If a plus b plus c is equal to 15 and a, b, c are positive integers, then what is the maximum value of a plus b plus, a into b into c? So I know if the sum of the numbers is fixed, their product is maximum when all the numbers are equal. So all of them would be 5. The maximum value of their product ABC would be 5 cube. What is the maximum value of a into b plus 1 into c plus 2 in the above question? Now whenever you have a question of this type, you always need to modify your equation as per your needs. So what you do is, you do a plus 1 here and you do a plus 1 on the other sides. That's completely okay. You do a plus 2 here and you do a plus 2 on the other side. So what is it? This is 18. So a plus b plus 1 will be treated as a separate variable and c plus 2 will be treated as separate. So this I can take it as x plus y plus z is equal to 18. What is the maximum value of x? Into y into z. All of them to be equal to 6. So this is 6 into 6 into 6. The value will be 6 cube, which will be 216. Another type of question is, given the product, what is the minimum sum? It's actually a kind of reverse that you have for the previous case. For the positive variable, if the product of the variables is constant, then the sum of the variables will have a minimum value if all the variables are equal. So what is it? If the product is given to you as fixed. Now what are the possibilities? This could be 1 and 16, it could be 2 and 8, it could be 4 and 4, 8 and 2, 16 and 1. Their sum would be minimum if the numbers that you take are equal. In case it is not possible for us to get exactly a equal to b, we'll get a as close as possible to b. So if I give a into b is equal to, let me take a value which is 15. Now I know 15 cannot be broken down into a product of two numbers which are same. So if I just look 1 into 15, 3 into 5, 5 into 3 and 15 into 1. So the two numbers that you select has to be, the minimum value would be when the numbers are as close as possible to each other. A and b cannot be exactly equal to each other, but a and b can be approximately equal to, or the difference between a and b should be minimum possible. The other way this question could be looked at is, instead of a into b equal to 16, I give you some values, a raised to power m and b raised to power n is equal to a product that I give you. And I don't ask you what is the minimum value of a plus b. I am not asking you the minimum value of a plus b. I am asking you the minimum value of a plus b with some coefficients. Let's suppose what is the minimum value of 3x plus 2, what is the minimum value of 3a plus 2b. How to deal with these type of questions? So what you have is, you have x raised to power m into y raised to power n is equal to a product. You have to find the minimum of ax plus by, another minimum of x plus y. So in this case, you have to remember the scenario that you will be using to finding out your answer. You will do ax over m is equal to by over n. Let's take an example that we have. Given that a square, b cube and c is equal to 27 into 2 raised to power 8 and a, b, c are positive variables, then what is the least value of a plus b plus c? That is the question that we have here. Now look at it. What I have to do here is this thing. A square is there, b cube is there and c is there. And the value that I have to find is for a plus b plus c. So what I'll do is, this is what I start with. So if you remember the rule, it is a raised to power m into b raised to power n is equal to product, and you have to find out the value of xa plus yb. So this xa will be divided with m, yb would be divided with n, and both of them will be equal. So what is this? A divided by 2 is equal to b divided by 3 is equal to c divided by 1. So I'll get the relationship between a, b and c. I'll write a is equal to 2c, b is equal to 3c and c is anyways in terms of c. So now whatever is given to me, a square b cube c is 27 into 2 raised to power 8 would be written all in the form of c. So a is 2c. So this is a square, this will be 4c square. B cube, b is 3c, this will be 27 c cube into c is equal to 27 into 2 raised to power 8. So this 27 will get cancelled out, right? So if you look here, this is 3, 4 and 6. This will be 2 raised to power 6. The value of c comes out to be 2, a will be 4 and b will be 6. So the least sum of a plus b plus c would be 4 plus 6 plus 2, which will be 12 as my answer. Similarly, in case you are given xa plus yb equals to the sum, and you have to find out the maximum value of a raised to power m into b raised to power n. What will I do? I will divide xa with m, yb with n, and the sum would be divided into m plus n parts. This is very, very important for solving the questions related to this type. Now the question that we have is, if a plus b plus c plus d is equal to 1, then what is the maximum value of 1 plus a into 1 plus b, 1 plus c, 1 plus d, given they are all positive integers. Now what is there? A plus b plus c plus d. Now this is a type of question that we have already done. What I'll try to do is, I'll try to modify the left hand side as per the requirements for the product. So I just want this values. So if I've added 4 on the left, I'll add 4 on the right as well. 1 plus 4, which is 5. So this is something like capital A into capital B into capital C into capital D is 5. Find the maximum value of A into B into C into D. So that will be possible when all of them are equal to each other. Now here it is not possible for us to make them exactly equal, because it will be 5 by 4. That means the value would come out to be 1.25, and all are positive integers. So the possible way would have been 1, 1, 1 and 2, 2, 3, 4 and 5. So you have to find out the maximum value. It will be 1 into 2 into 2 into 2, which will give me an answer which is 2. The next method of solving the questions in maxima minima is the application of arithmetic, geometric and harmonic mean. For positive real numbers a1, a2, a3, so on up to an, the value of arithmetic mean would be sum of all the numbers divided by the number of numbers or the count of numbers. The geometric mean would be given by the product of all the numbers and the nth root of that. Harmonic mean is given by n over 1 over a1 plus 1 over a2 plus 1 over a3 and so on. If you find out the am, gm and hm for a certain set of numbers, you will observe that the value of arithmetic mean is always greater than geometric mean, is always greater than harmonic mean if the numbers are not equal. And if the numbers that you take are equal, am will be equal to gm will be equal to hm. Let me take two numbers, 8 and 2. You can find out the arithmetic mean, 8 plus 2 by 2. So this is coming out to be 5. You can find out the geometric mean, which is 8 into 2 square root, because there are two numbers, 16, square root of that is 4. If you find out the value of harmonic mean, it will be 2, 1 by 2 plus 1 by 8. Again you need to take the LCM here as 8. This will be 4 plus 1, which will be 5. So this will be 16 by 5 is the value that you get for HM, which is 3 point something, 3.2. So if you will observe, am will always be greater than gm, will always be greater than hm. This is a method that you can use to find out some of the questions or to solve out some of the questions related to maximum or minimum value. Now am's minimum value will be equal to gm, gm's minimum value will be equal to hm, HM's maximum value will be equal to GM, GM's maximum value will be equal to HM. That is the concept which is used. Another way of finding out the maxima and minima points is using the graphical method. So let's look at a question. The question is, plot the graph for the given equation and find the maximum or the minimum value. The function which is given to us is a minimum of two functions. You have to find out the maximum of this function or the minimum of this function. Now how I do it, I plot these two graphs individually. So if I look at the graph of 2 minus 3x, this is the graph of 2 minus 3x individually. I'll look at y is equal to 2 minus 3x. I'll look at y is equal to x minus 2. X minus 2. So if I just solve the graph for this, I would look at it. These are the graphs and this is what is intersect. The blue line is for y 2 minus 3x and the red line is for x minus 2. Now I have to draw the graph for fx. Fx is the minimum of both these functions. So if I look at the critical point or the point of intersection, if I look at the area on the left side of the point of intersection, the minimum would be given by the value which lies bottom. So I'll take this value, which is actually the part of x minus 2. And if I look after the intersection sign, the minimum of the two graphs is given by 2 minus 3x. So if I look at it, this graph is the graph that I have for fx. Now for this fx, I can find out the maximum value. Maximum value of fx would be at x is equal to 1 and would be equal to minus 1. So maximum fx is equal to minus x for x is equal to 1. What I do is I make the graphs individually for these two lines, then I try to make a combination graph for fx and then I look at the maximum or minimum value. Again, if you look at the question, find the minimum of x minus a, x minus b and x minus c. These all are in plus that you have. Now this is a typical question that we have. If you draw the graph of this function, it will look like this. Now I'm not asking you to draw the graph in paper because it is virtually not possible for us to do that thing because of the paucity of time. So the thing that you need to know is the minimum value of this type of graph would either be at a or b or c or the average. So there are 4 points that at which I'll be checking the graph for the minimum value. I'll not be able to find out the maximum value of this graph because it will be a graph that will move from infinity to infinity. The maximum value would come out to be at infinity. So the minimum value would either be at this inflection point or this or this or at an average of A, B and C. Thank you so much for watching the video. I hope the concepts of maxima and minima are a little clearer to you now. You can move to our website now and look for practice questions on maxima and minima. Thank you so much. Have a good day.